in Daniel's example, we had, we had random numbers, right? And if we want to check that an item is in the array, a number, we have to look through every one of these, right? One at a time.
Are you sharing your code, Max?
Oh, sorry. All right, so to repeat, if we have an unsorted array and we're looking for an item, we have to check each of these items one at a time. There's really no way around this. And this is linear time, right? Which, Ronald, what did they say about O of n in your chart? Like, not good or something?
Yeah, I don't know.
Something like that, right? It's not awful at all. We use for loops constantly, right? But it's not, if we can do better, we'd like to do better. So I asked ChatGPT to make me a sorted array of 20 items. So let's copy these. And then the story changes. Let me expand this. So our story changes. If we have a sorted array, we now have the ability to do binary search, which is going to be O of log n. And what does that look like in our little chart, right? So this is going to be better than linear time, which is why we're doing it. So linear time, as the input size increases, the operations required increase. So same thing here. It still increases with log n, but it increases at a decreasing rate. So still increasing, but the rate that it increases is less and less and less, which is really cool, especially if you have like big numbers, big data. So how can we implement, or what's the idea of binary search here? You really need, for binary search of an array, you really need to keep track of 3 variables. So this I'm going to call like low index. And this I'm going to call high index. Whoops. And I don't know exactly where the middle is, but here I'm going to say middle index. So for binary search to work, we need to keep track of these 3 items. Then the cool thing, you just ask yourself the question, is the number I'm looking for equal to the middle index? If it is, just return that index. If it's not, we have to ask ourselves the questions. If the target number is greater than the value of the array at middle index, what does that tell us? What can we infer? So we're looking maybe for the number, 60 right now. We check our middle index value and it's 42. What can we now infer because we have a sorted array?
But it's in the second half of the array.
Yeah, so if the middle index is the value at the middle index of the array is less than our target, which maybe is 60, we now know that we don't have to bother checking all these numbers. And now what we do is set the low index to be the middle index plus 1 because we know it's not the middle index already. The high index remains unchanged. And the middle index, whoops, we calculate a new middle index. Then we have to ask ourselves the same question. So is my number that I'm looking for 68? And if it is, we return that index. If it's not, let's do the situation where it's less than. So the value of the array at the middle index, wait, did I do... Say we're looking for the number 56 and the middle index... No, sorry. Say we're looking for the number 77 and the middle index is 68, so it's less than. Target number is less than. Did I say this wrong? If target number is more than. Yeah, if target number is more than, then we would cross off all that. So let's actually say, we already did that example. So let's actually say it's less than. Yeah. So the number we're possibly looking for is 56, and the value of our middle index number is 68. We now know that we can cross off all these numbers. And now we can compute a new high index, actually. So now our high index moves to the middle index minus 1 because we already checked that. And then we have a new middle index. Sorry, where? Middle index. Oh, yeah, 263. Yeah, and this is still crossed off. And then maybe we're looking for the number 56 and we find it because we do. We check, is the middle number, or is the value of the middle index number of the array the value we're looking for? So the idea isn't complicated, but coding it out can be, as you can see, I'm struggling, can be a little complicated. But the idea itself is not complicated. If you know your number is bigger than the number you checked, and you know all the numbers are less than the number you checked, just throw away those other numbers. There's no point in wasting your time. That's the overall concept. So we're going to try to code this out. But any questions on the overall idea? All right.
So I had a question. So that it mean like we can use some kind of sort to sort the array at the beginning, or I can get the sorted array at the
No.
beginning?
The premise is that we have a sorted array. We're not talking about sorting at all right now.
Okay.
Yeah. We'll talk about bubble sort. I don't know how much time, if we're going to cover it today or not. Maybe not, because we're running a little late. Okay, so let's code this idea out, right? Let's grab this code. And what are we doing? Binary search. So binary search is going to take in an array and a target, the number we're looking for. And if it doesn't find the target number, I want to return -1. So let me invoke binary search and pass in random numbers. And let's just say we're looking for, it doesn't matter, 14. So I'm going to wrap this in a console.log to see if this is all wired up correctly. And then let's run this. Okay, so we're good. So now I want to define those 3 variables that I talked about: low, middle, and high index. So I need to define these variables: low, middle, and high. So someone help me out. How can I set the low index originally? What is the low index going to equal to?
0.
Yeah. And how about the high index? Daniel?
Do you want to make it like the last number in the array?
Not the last number, but the last what?
Oh, the last index of the array.
Yeah, so how can I get that?
Would it be -1?
-1 of what?
So index -1 of R.
R is an array, so array -1 doesn't make any sense. But what property can we ask
You'd
for?
You'd have to. Could you just put it in the square braces? The square.
Oh no, we
brackets?
can't do this. No, is that what you mean?
Yeah.
And that wouldn't do anything for us if that worked, because that would just give us, I don't know what that would give us. Someone who uses Python might know. I don't remember.
It would give you the last number, I think, in Python.
Okay. But it doesn't work in JavaScript. So how can we get the last index?
Array.length minus
there
1.
we go. There we go. Because array.length will be 20, but we only have 0 through 19 indexes here. Yep. And now the most interesting, how can we calculate the middle index? So in this case, we wanted to calculate like the middle between 0 and 20. How can we do that? It shouldn't matter the size of our array. How can we calculate the middle index?
You add the low index and high index divided by 2.
Yeah. So
Max,
yep.
could I ask a quick question? Sorry, I'm a bit confused because aren't the values you're giving it when they be the actual numbers when it be the number of items in the array rather than the numbers themselves?
Correct. The number of the items in the array is .length.
Okay. But would you not want do you want high index to be the total number of items in the array, or do you want it to just be the highest number?
I want it to be originally what we defined here. So I want it to equal, I want it to literally be like the number 19. And here, when it first starts, I want this to be the number 0. But the thing is, these values are going to change. Maybe this originally is, I don't know if it's 9 or 10. It doesn't really matter.
Okay, got it.
Yeah.
Thanks.
So if we do 0 plus 20 divided by 2, that's 10. That's fine. But what if our low index was 10 and our high index was 20? Now we have 30 divided by 2, which is 15, that's still fine. But sometimes you're going to have a situation where it's a decimal, right? So we're going to round it down. What if we just had our low index was 1 and our high index was 2? 2 plus 1 is 3, divided by 2 is 1.5. So we want to round this down, this number. And now for a sanity check, let's just console.log all this stuff out. Oh, let me put middle index in the middle. So 0, 9, 19. That's all fine. So then what is the first thing we asked in our drawing? Is the middle index, is the value of the array at the middle index equal to what the target I'm looking for? Is the value at the middle index equal to my target? How can I say that? How can I ask that question in code? Zach?
Sorry, Max. Could you say that again?
Yeah. So the first question we want to ask, now that we've computed our middle index, is the value of the array at the middle index equal to our target? How do I ask that question in code?
You want to use an if statement?
Yeah.
And you want to say if I'm not sure. I'm not sure if it would be r dot middle index.
Very close.
Square
we
brackets,
need the
middle
square
index.
brackets because we need it to be evaluated, the variable. If this is
if
equal
that
to what?
is strictly equal to target.
Yep. And if it is, what do we want to do?
Return middle index.
Yeah.
Or return target. I guess it should be middle index probably.
Yeah. So we're just going to return middle index. But if that's not the situation, what did we say we want to do? So if target number is greater than the value of the array at the middle index, we wanted to recompute the low index and the middle index. But let's write this in code. So let's do the situation where the target number is greater than the value of the array. Then the value of the array at the middle index. God, my room is so bright, I can barely see my screen. Okay, how do I ask this question in code? Jazz?
So you make another if statement, and then if open close parentheses, if target is greater than middle index.
Not middle index, but close.
Array middle index.
Yeah, the value of the array at middle index.
And then if the target.
So we have to recompute the low index and the middle index in that case. The high index remains the same. So we're basically throwing out all the values below the middle index, inclusive of the middle index too. So any ideas? This is pretty tricky, but any ideas there? How can we modify the low index number? Right now it's 0, but what do we want it equal to?
want to change the low index? Low index equals middle index plus 1.
Beautiful, yeah. And why the +1? You're right, but why?
Because you want it in front of the middle index. You're already.
So in this case, our middle index was 42 or 9, but the value was 42. We already checked 42. We don't need it. So we go to 47. So that's why we have the +1. Else, so this case, if the target is less than the array of middle index, what do we want to modify instead, and how do we modify it? So this is the situation where here, where we're changing the high index and leaving the low index alone. So how do we recompute the high? Oh my God, what is happening in my world? Yeah. So what's our new computation for high index?
Middle index.
Middle index. And same logic here, -1, because we've already checked. Where are we at? Target is okay. So we're in the situation where like we checked. Yeah, we're in the situation where we're looking for 60 and we check the middle index and 60 is less than 68. So we move our high index to be 1 less than the middle index. Yeah, because we already checked the 68. So we don't need that. Yeah. Let's make sure we're okay just by console.logging this stuff out. So yeah. So we have 0, 9, and 8. Random numbers with 14. So low index, middle index, high index. Somewhere I have a bug, right? Because middle index should never be more than... Oh, no, because high... Oh, sorry. We have to... Okay, I get my bug. There's one more thing we have to do, right? We have to recompute middle index. And I can just grab this code up here. So after we determined if the target is less than or greater, we have to recompute middle index. Now this makes way more sense. 0, 4, and 8. But the problem is we want this to repeat itself, right? Again and again and again. So how can I get this code to just keep on repeating itself?
Put it in a while.
Yeah. So I'm just going to throw this in a while loop. And I'm looking for the number 14. So that's fine. See right here, we can delete this. See how right here it gave me the index 3. 0, 1, 2, 3, 14. Perfect. But there's still a problem with this code, right? Does anyone know what the problem is?
Yeah, if the target isn't in the array, it'll just go on forever.
Yeah, it's an infinite loop if the target isn't in the array. So, can anyone propose a fix for that? How can I break out if I determined if I've checked every number, or I haven't checked every number because it's binary search, but I've done my work to determine the number isn't there. How can I break out?
If your low index equals your high index.
Yeah, exactly. And then here we'll just return -1. And then here I can delete that. So what I like to do is to check my lowest number, 5. We should get 0. And check my highest number, 19. Very nice. Check something in the middle, 51. And then check something that doesn't exist, -1. So, so this is going to be your mock technical for today to generate this. We don't have time to do bubble sort, so maybe we'll leave that for tomorrow. It's tricky though, right? So try to understand this as best you can, but then you're going to have to repeat it today. Try not to just memorize it. Try to understand the idea. Just memorizing it and then you do it today and then you forget it isn't going to do us anything. So try to understand the basic idea and then you can recreate it. It's tricky though. Like I was sweating doing it. So any questions on binary search? The idea is so simple, but then doing it is kind of tedious.
I have a question. In the in one of the YouTube videos for the pre-work, they had the middle index defined inside of the while loop, and then just like once, and then also the parentheses. It said like the low index less than or equal to the high index.
Okay. Yeah, that's kind of the same thing. We would just get rid of this code block, and we're putting that
that's what I was
here
asking.
Instead, kind of. So either way is totally fine. I don't understand the not computing a middle index. That seems weird. I don't think that could be correct because you have to recompute.
No. They had it in there. Oh. It's just right under like after the while loop. So like line 13, that's where they had it.
Yeah.
And they didn't have it on line 10, essentially. So it was just defined once.
Okay. Yeah, there's going to be a lot of variation to how you can do this. I think I'm the only one who uses like low and high. I think most people use like left and right. I don't know. Whatever makes sense to you is totally fine.
Max, I have a question.
Yeah.
What type of big O notation is this?
Oh, that's a great question. So, well, it's log n, right? So it's going to look like this. Yeah.
I see. Thanks.
So as input increases, time increases, but at a decreasing rate. So this is like the evil twin of, I mean, the good twin of n squared of quadratic time. This is the log n is like a great place to be. Your number set could be like trillions and it's just like no time at all. It's really powerful. All right. Any final questions while I still have a shred of vision? I have no idea what's going on. I can barely see right now. I think it's because I have a flu. All right. Thank God. Let's get you to the breakout room.